Assalamu alaikum. First of all, thank you very much for inviting us here. It was a big honor for us to serve the customers for money, but it's a very rare opportunity that we come and serve our institutions who have contributed to our growth, to our career. So I'm really humbled, I'm really truly humbled and honored to be here. So I'll try to share some experiences of what I have learned in the last 20 years and a bit knowledge sharing about the trends of future, what's happening in the industry. Because what I've experienced that generally there is a gap between academia and industry. But I'm also glad at the same time that UEB especially is playing a great role to bridge this gap. Today I visited different stalls, there are 4 or 5 labs, so I was not expecting so. So with the available resources that government is providing to academia, I think it's a merit that we are already doing. So thank you sir, आपकी great contribution का. So I will start with the agenda. It's a long list, so I'll skip which is not relevant. So, but first objective is to share what is happening in the industry, so that anyone who wants to use the technology, especially the cloud technology, for their projects, for their research, or for their future career, so they should have some platform, some foundation. That's the purpose of the session. So we will start with the cloud computing trends. Then there are different components of cloud technology. So we discuss that, primarily microservices architecture, containers, then the service mesh, serverless computing, then how this technology is affecting the data services architecture, then the API economy, DevOps, and lastly, there are different tools that different people are using, or frameworks which are using. So, this is a very basic idea of how the cloud computing has to work. First of all, are you familiar with the cloud computing? No, sir. From students, any question, any doubt? So what is cloud computing?
सर क्लाउड कंप्यूटिंग ये होता है कि हम अपना सिस्टम क्लाउड पे रन करते हैं, जो कि एक जैसे कि अमेज़न प्रोवाइड कर रही है क्लाउड की, तो हम अपना सिस्टम वहाँ पर डिप्लॉय करते हैं उस हार्डवेयर पर, वो हमें सिर्फ एक्सेस दे रहे हैं और उसको सिक्योर कर रहे हैं. इसकी बेनिफिट हमें ये है कि हमको अपना सिस्टम मेंटेनेंस उसका नहीं करना चाहिए हमें, इसलिए हमें एक्स्ट्रा चाहिए रिसोर्सेज जो कि उसको मैनेज करें, वो अमेज़न खुद कर रही है, तो ये इसलिए लोग
So there are two most important factors. First of all, cloud provides us resources, on-demand access to resources. Second important factor is we don't have to manage those resources. These are managed services. We are just consuming those services. So on-demand access, and second important factor is the managed service, managed by third party, not by you. So exactly like utility company. If you are using electricity at your home, you don't have, unfortunately we are not giving the example of Pakistan, you don't have a power station. We just have a device that measures the utilization of that. So cloud is basically IT, I would say, information technology as a service. There are different variations of that. We will see that. What are the different variations? So it was started in 1960s. 1960. It was a news for me because there is one foundation technology for cloud. If that was not there, we couldn't have used cloud. And that technology is virtualization, computing virtualization. We learned that technology was available for x86 architecture in early 2001 में VMware ने probably इसको किया. लेकिन 1960 में when mainframe was developed by IBM, they were born virtualized. They were born virtualized 1960s. So virtualization का concept was there. So they just utilized that concept for x86 architecture. So second step, 2001 में when this virtualized computing was available, because we could share one physical resource with multiple tenants or multiple users at the same time. हम एक server के ऊपर we can have multiple VMs. Similarly, when you acquire Amazon, Azure, Huawei Cloud, and cloud, actually you get access to a VM. You get connected to a VM. EC2 is a VM, virtual machine. So why we have efficient utilization of resources? Otherwise, if there is dedicated physical hardware for every user, every individual user, then commercial cloud cannot exist. Because you cannot have a dedicated machine for every person. Otherwise, the data center would be of miles. It cannot be like a one or two rooms data center. Okay. Then second thing to discuss about AWS, they have actually commercialized this concept. The technology was available, they commercialized this concept and they made it available for the end users. Okay, in this era, up to 2010 generally, it was infrastructure as a service primarily. What does it mean? Infrastructure as a service means we provide server, storage, compute, storage, network. Primarily these three services, plus security. But there was another silent revolution coming in the computing technology that was initially in the labs, but it was actually there was a great contribution by Google to make that commercialized. That is microservices computing. The utilization of containers. That concept is also important because that technology existed since 2001 in the form of secure computing groups in Linux, but that was never utilized for the application deployment or for the application level virtualization. So thanks to Google, they also developed Kubernetes, which was a management engine. And then they made that publicly available, because now it's not a proprietary of Google, now it's an open source technology, Kubernetes, but it was actually developed by Google. So 2014 onward, this microservices architecture or cloud native computing just started making. So in this era, there is another important player, which is Docker. Docker actually utilized this technology of containers and they started selling it or started implementing it like a virtual machine, like VMware. So commoditization of technology is very important, the commercial aspect. The technology that exists in lab and the technology that is being used in industry, there's a big difference in that. And what the company who made it commoditized, actually that company is changing the industry landscape. So Docker made it commoditized, and secondly this Kubernetes. So this combination that was matured in 2017 onwards. We call it Kubernetes plus OCI. This became the industry standard for cloud computing. In between, in 2015, there was a foundation developed, Cloud Native Computing Foundation. Actually, this is a subcommittee of Linux Foundation. So all this technology actually evolved from Linux. So Linux initially governed this body, then Google, IBM and some other companies, they started working on it. And today, there are, I think, 26 members of Platinum, okay, technically, who are contributing. It's not about It's primarily based on the technological contribution that these companies are making. So Huawei is one of those, IBM is one of those, Oracle, Red Hat, there are many companies, AWS of course. So what they are doing, actually they are providing a platform where they are developing standards for interoperability for cloud computing. So how the computing will actually work, how the containers will work, how the containers will talk to storage, how the container will use network, what network standards they will follow, what security standards they will follow. Everything is being governed or developed by this body, okay, through different projects. So these are the list of projects that they have developed. So you can see Kubernetes is now part of this CNCF foundation, okay. And now there are many other projects. ETCD, I just want to share a simple example. ETCD is like a registry. People who have done programming 10, 15 years back. So if you write a code, if you want to save some configuration on a Windows server, you actually create some registry, in Windows. So it's a key and value configuration. So it's a similar concept that we are using in this platform now. So what are the founding pillars of this architecture? Number one, microservices. Okay. Second, the PaaS technology. Third, the containers. Fourth, the orchestration engine. Fifth is the automation. Let me share one example. Then I think I'll be able to better explain this architecture. Okay. For example, we have a banking application. I'm using a mobile application, okay, for my payment transfer, for payment of my bills, okay. So there's an app that I'm accessing. Then this application is hosted on cloud. This application is connected with Nagra for the verification, CNIC verification. Okay, this application is integrated with for example, Lesco for the payment of the bill, because the bank, if my bank is not giving me the electricity, they don't have the billing data, so they are just using an API connection, okay, to get the billing details. Similarly from a credit card, similar from a mobile. So this API gateway actually connects me to different components or the different backend services that this mobile application is providing. We call it generally super app. So because the functions or features those are being provided in that app, those are not coming from one vendor. Actually, there are multiple service providers who are providing this capability through an interface. So this API gateway. Then we have backend microservices. For example, there is one microservice for bill payment of Lesco. There is one microservice for credit card payment. There is one microservice for funds transfer. And there are different layers. So I'll explain this in the following slides. So microservices, how to develop microservices. So I think the people who have studied the computer science courses, microservices, they should be familiar. It's a very, very important basic concept. Previously, when we were developing applications, we were developing large applications. Those were tightly covered. There was one big application and it has one database. What is the challenge with that? First challenge, the maintenance of that application is very difficult. Okay. For example, if we talk about the same banking application, if there is one application behind and if I am changing any code in the fund transfer, so I have to rewrite or rerun the complete application, मुझे पूरा code rebuild करना होगा and then I have to redeploy the complete application. So the big applications take hours to deploy, to upgrade. Sometimes days, sometimes weeks. The core banking applications of our Pakistani bank, those are developed on traditional architecture. It takes them sometimes weeks to upgrade those applications, to deploy the applications. So it's very time consuming. Whereas if you use any other third-party service for a mobile banking application, it just upgrades in a few minutes. Why? How does this happen? Because they break that application in loosely coupled components instead of tightly coupled components. So that if you have to change one component or upgrade one component, you can do it independently. It should not be dependent on the other components. So this software engineering principle of loosely coupled architecture, so we use that principle and then we can manage the maintenance of different components or microservices of that application easily. So there is an example, for example, this robot which is deployed under this machine, okay, it is working independently, but the one which is deployed on top is tightly integrated with the whole machine. If there will be any change happening, it is affecting the whole architecture. So this is an example of the application I'm talking about, a similar application. It has different interfaces, web application, mobile application, traditional application, okay, maybe on PC, which is talking to the API gateways, and then on the backend. For example, if it's an online shopping portal or app, so there is a service for identity microservice, for example, for user authentication. Second one for catalog, different type of services that they're selling. The order management, whatever order you are placing, and the basket services. So every service is independent. It's not connected with the other service. It has its own database. There is no one single database. So first step is the maintenance, because the operation of one application is very difficult when it is running in an industrial system. For example, I give you example of core banking. For example, I am talking about the billing system of a telecom operator. There is no downtime. There cannot be any downtime for billing system because everyone is doing the calls anytime, 24 hours. I am traveling, someone is at airport, someone is at hotel, someone is at hospital. So 24 hours, round the clock, people are using that service. So if the billing system will be down, so they cannot track the billing, and that would be revenue loss for the company. The calls those were being made at that time, that would be serious revenue loss. So billing system, so the industry needs to develop or transform their traditional application in this microservices architecture to maintain to ensure the low cost maintenance or low impact maintenance of those applications. So container, what is container? When we develop those applications, so we deploy those microservices on container. Container is a runtime environment on which we create an instance. Okay, it's exactly like VM. But VM, what's the difference between VM and container? In case of VM, the operating system is also residing in that VM. In case of container, we are doing application virtualization. There is no dependence on the operating system. Operating system is not directly connected with the app. App has its own Windows libraries, and then there is a container runtime environment. So actually this is helping us to create loosely coupled architecture. Second thing, we can dynamically move these container components from one cloud to another cloud. So we talk a lot about hybrid cloud. So in VMs, hybrid cloud was not technically possible. There were many serious technical challenges. Why? If the VM size is 5 GB or 10 GB, or if it's a big database, it's 10 terabyte, how would I move the VM from one data center to a public cloud or from Google to Azure on runtime? It will take 10 days to move one VM from the network, from one data center to another data center. So it is only possible through microservices. because those are live view. So you can dynamically move the components from one cloud or one platform or from one operating system to second operating system. Truly at runtime without any impact. So when you have VM, when you break your application into smaller components, then you need a manager as well, orchestration engine, because there are many small components and you need some console to manage those components, because you cannot manage the individual component at its own. There should be one orchestrator. So Kubernetes is that orchestrator. The people who are familiar with VMware, so vCenter is that orchestrator for VMs. But in case of VMs, when very large scale data center, for example, one big bank of Pakistan, one big telco of Pakistan, they have 500 VMs, maximum 1000 VMs. But in case of containers, it can go up to 10,000 containers, 1 lakh containers, 1 million containers. There are big banks in Pakistan, sorry, in our region, who have transformed their application from traditional architecture, monolithic architecture to microservices architecture, and they are running more than 1 million containers in their data center. So how to manage those 1 million containers? So Avaya is providing this CCE Cloud Container Engine. This is a managed service for our public cloud or private cloud. Similarly, AWS, Google, everyone is providing this service. So because why they are providing, CNCF is providing that foundation. It is just a marketing package for some enhancement. The foundation technology is being provided by Cloud Native Computing Foundation. Okay. So now when we have multiple microservices, we need to manage the communication between the services. Okay. So previously we were using enterprise service bus. For example, we were talking about this example. Okay. So if different application components from different parties, for example, Nadra, for example, this we talk about the banking application, Lesco, those were the external collaborator. Those were the APIs or services we are using externally. But there are many applications that we have internal. For external communication, generally we use API integration services. Okay. For internal communication, we need service mesh. Service mesh is a technology that actually ensures the communication within the data center or within one cluster between different microservices. Now next is serverless. Serverless is technically the same thing. There is only the marketing difference. I would put it straight. This is the marketing difference. In case of IaaS, what do you do? In case of IaaS, you acquire VMs. Okay. On VM, you deploy your own operating system, and on your own operating system, you deploy your application. In terms of container, what do you do? You acquire a platform where you deploy containers. Okay. Because container doesn't contain the operating system. Operating system is already at the cluster level. So you only need a management engine, Kubernetes, and you only deploy the container. And for this integration, there are few other components. One major component is the service mesh. Okay. What type of workloads you deploy in containers? Generally, the stateless components. Okay. For example, there is one cron job running. Every day, every night, they run end of day batch. What is that batch? That batch will trigger at the end of at the closing of the branch time. For example, 5 p.m. is the closing of the branch time. After that, we go to WhatsApp, the normal banking services. So after 5 p.m., they run a batch job runs automatically. It collects the data of all the account holders and it settles the debit and credit. Okay, because we are performing different tasks. We are performing debit credits. We are doing the payment transfers. We are doing the bill settlements. So day and job will actually settle the account. Okay, so that's a cron job. Cron job will run, and after it completes this settlement, it will not hold any. The data will be placed in the core banking system. So if we deploy our own cluster to run this job, we have to manage that cluster as well. What if we only use a function, okay, like an API, okay? We only use a function and the service provider is managing everything, okay? So it is a container which is being managed by the service provider. It is being managed by the service provider, and it has certain life. For example, you will use it for 2 hours. Once your job is finished, this container will automatically be destroyed. Okay? So for stateless workloads, we use serverless computing. Okay, serverless is a fancy name. Actually, it's a container. So why we use it? It is very easy to manage the billing, because if it is being consumed for 2 hours only, or 30 minutes only, or 5 minutes only, the billing will be done on 5 minutes basis. So it's easy to understand. The businessmen, okay, they decide that, okay, there are core banking application, there are a few sources where they need stateful data, then there are certain workloads they need containers, and third category, totally stateless container, and they don't need to manage that infrastructure. Okay, so they can reduce the cost of their billing operations. Sorry, your words, but I am intensely emphasizing this point. That is the difference I was talking about, that you must consider the commercial aspect of the applications that you are developing. Why these technologies exist and what is the commercial aspect. Okay, so serverless has better commercial value, that's why it's being consumed. Technically, it's probably the same thing. So different companies are providing this capability. Just the branding is different. AWS call it AWS Lambda, Microsoft Azure call it Azure Functions, Google call it Cloud Functions, Huawei call it Function Graph. So this is the comparison. This is the virtual machine. It has hardware, operating system, hypervisor, and on top there is again a private operating system for each guest machine. Okay. In case of container, we have hardware, operating system, container engine, and then we have container. In case of serverless, actually it is exactly same, but we have abstracted the technical aspect of this technology from the consumer, from the customer. We are just providing this as a service, this API. Okay, as a managed service. Okay, what is Knative? Knative is the same thing. It's a serverless technology, but they have made it industry standard. So Cloud Native Computing Foundation, they have created this standard, and this technology is also available as open source. So you don't need to buy these services from IBM, Google, Huawei, Amazon. You can easily acquire download this service from Cloud Native Computing Foundation website. Like the other open source container platform, you can also get this serverless computer. As I mentioned, we also provide this capability, and we provide this Java, Go, Node.js, Python, C# and PHP capability with this wall function graph. Okay. We were talking about the stateless workloads. Now we talk about stateful workloads because we have to store the data as well. So to store the data, there are different types of storages. Again, some staging area storage, some permanent storage. For staging area, we use caching. For permanent storage, we use databases, file and object storage, block storage, the different types. Over cloud, we have different choices of databases available. Generally, for OLTP workloads, we use relational database, RDBMS, and for OLAP, we have different data warehousing services. And in addition, we have the choice of NoSQL database, document database. So, more or less, all the cloud services provide these capabilities. So API, I'll spend a couple of minutes on this. This is important area because this is transforming the whole industry is working. We take the example of a bank. Today we talk about a bank. A big bank in Pakistan has 1,500 branches. Okay. And they have more than 15,000 employees. But the new era, there is no physical bank. Okay. I was part of one project where in Singapore they have deployed a new virtual digital bank that doesn't have an office, and that office that at that time completely resides in the data center. How that bank operates? If there is no branch, how that bank operates? How they make money? So this is the way they make money. API. Actually, they collaborate with different stakeholders. There are banks who are not providing the traditional loans, but they are still doing banking. We call it open banking. Different fintechs are providing different services. For example, for microinsurance, you can acquire a microinsurance on your mobile. So, ABC company is providing that microinsurance. That is their one service. But in order to do the fund transfer, in order to manage the financial cycle, they need a bank at the back. Okay. So they have collaborated with a different bank. Initially they were collaborating with the physical banks. Now they are collaborating with the virtual banks. Why? Physical banks generally they charge more premium. Their cost of operation is very high. If it's a virtual bank, you know, if I just give you one example. For example, a bank which is the branch outside the university, they will be paying minimum 5 lakhs upfront for one branch. There will be 5 lakh employees working there. Their monthly operational cost will be minimum 2 to 3 million PPI. Very small branch. So you can start your own virtual digital bank. Maybe you host that bank on public cloud. You only pay 2 to 3 million PKR. The cost of one branch for hosting the whole bank in the data center. Okay? So the operational cost of a virtual bank is very, very big. So that's why even the major banks, they feel that they will have better reach due to this mobile applications. There will be more people using the mobile banking services instead of physical branches, so that there is a customer shift. Secondly, the cost of operation is low. So in the next 5 years, you will see that this complete banking will transform. In next 5 years. It's already happening in other parts of the world. In Pakistan, it has started happening. In this year, State Bank has shortlisted 5 virtual digital banks to whom they are going to issue the licenses. And they have already started their operations. The trial run is already It's already happening. So, formally they will launch their services in next 2023. Yeah. So how is happening? Because of API economy. Sorry if I am taking time, but I think this is important to convey this message to the students. So why is happening? API economy, API gateway. So you know it's a technology API gateway, but they call it API economy because of this technology they can transform the technical data center to a business model. Okay. So more or less all the companies they are providing this capability. So technology is not an issue. Since last 10 years, everyone has almost everything. So it's not like that the Scandinavian country will have this technology, or America, or North America, or South America will have this technology. Now everyone has everything. Last topic is about the DevOps. So now we have all these technologies available. We were talking about the application components we are using. So individual components are there, service mesh is there, the development tools are there, but we have to manage the life cycle of application. Because now the bank is not a branch, now the bank is not a head office, now the bank is that application. So if that application will be down, so they cannot survive. Customer experience matters. So in order to manage the customer experience, they have to ensure that the application development should be smooth, should be fast, agile. We heard this word agile a lot. So actually, in order to implement the agile practice, we need DevOps. Without DevOps, we cannot implement the agile practice. Otherwise, agile will be in the books or in the plans only. So DevOps provide different tools from development, testing, release management, deployment, operational monitoring, everything. And then rebuild because it's a continuous improvement. So we call it continuous integration and continuous delivery. Why I call it? Because there is no one service that banking will be offering now. One bank will be offering tens of services and they are continuously developing those applications. Okay? Continuously developing. There is one service, generally the application rollout time in Singapore or in the developed countries is 3 days. Within 3 days, they design an application, they roll out and they get the feedback. They feel that, okay, if this new service, customers like this service or not, if they like it, they mature this capability. Or if that service is not good, the response is not good, they just destroy that idea. It's not like that they take 6 months or 1 year to design one new product or one new service and they get the feedback after 1 year. It's not like that. Within a few weeks, they perceive the idea, they develop the application, they roll out and they test the feedback. Not the technical test, I'm talking about the business test. Like if they spend like, for example, $20,000 on that application, okay, on that service, so they are getting the ROI or not. If they are getting the ROI, they will continue building that. So how it's possible? Because of continuous integration and continuous delivery, release management, operation, everything. So it's not one product. So this whole practice, there are hundreds of tools different people are using. Okay. There is one open source technology, Jenkins, that was providing this capability. It's a kind of orchestrator that was providing this capability. Okay. Now it's also part of Jenkins. Jenkins was partially acquired by Microsoft, but still it's comes under open source. Yeah. So they collaborate with different software tools for deployment, testing, build, and this whole ecosystem. You see, these are hundreds of applications. Those are available on GitHub. People have developed this application just for DevOps. It is such a big market. This software in 2017 or 18, I think they sold the partial share and that was $8.5 million profit. Only this software. So finally, this is the example of one reference architecture of a bank. Okay, we talk about different components. For example, there is the end user who is using the security services to connect to the banking application. This banking application is hosted on the VPC virtual private cloud. Okay, and this is actually the virtual bank I was talking about. This exactly the same thing is deployed in Singapore for Greenline Bank. In this VPC, they have this container engine. It has different pods, okay, and then through the MQ services of Apache, it connects to the backend services and then to the database. For external services, we use the API gateway, okay. And for the security, data encryption, compliance, all these services are available on public cloud. Okay. So this is one complete bank deployed in a virtual data center. Any question? या बिल्कुल समझ नहीं आया, बिल्कुल मैंने ट्रांसलेट कर दिया या बहुत ज़्यादा दूसरी प्रकार से काम.
So I have you talk about the banking sector. Other than banking sector, I think telecom sector also.
Yes.
Has a sector. Which other sector?
Generally, retail is the first customer. Retail is the first customer. Utilities, banking, healthcare, wherever the customer are using different application. So actually, this is the new way we are designing good application.
So Huawei has its own footprint as a data center here in Pakistan.
Not a proper commercial data center owned by Huawei. Yeah, but in other countries we have 65 data centers. Actually, we had planned to set up data center in Pakistan. Unfortunately, because of political instability and all these issues, we couldn't do. Now we are doing it with the help of different partner organizations. There is one data center in NTC, National Telecom.
You said HAC is there.
Yes, there is plan that one.
Yes.
Yes, with HAC as well.
Kind of education.
Yes, that's the education cloud. So, Huawei is focusing on industry-specific clouds, so that it's not just about the technology, it's about the ecosystem, it's about the domain knowledge you bring. So, if you develop an education cloud, so with Huawei has very good relationship with academia in Pakistan, they understand this domain, and they have this, I would say, the intelligence, human capital available to manage this investment. Otherwise, that investment will be wasted. So, without parent investment, there is no value. So, education, why education cloud? First of all, they have students, they have partner organizations in the education industry who have that skill. So, that's why they are planning to invest in that. One area education, second, we are investing inshallah in banking.
सर ये जो serverless architecture आपने discuss किया,
Yes.
तो इसको थोड़ा describe करो. ये एक container है और एक आपने serverless.
So serverless, technically speaking, serverless is a stateless container. It can never be a stateless container. क्योंकि जब आप इसको use करेंगे और जब अपनी usage खत्म हो जाएगी, वो container भी destroy होगा. You cannot reproduce that. लेकिन अगर आपको दोबारा जब भी उस job run करनी है, ठीक है, तो वो automatically that serverless container will destroy. So you are not managing that container. So that container, the technology part is being managed by the service provider, but the cloud service provider. So that's why we call it serverless. So serverless, that's why I say serverless is a fancy name. Technically, it cannot be serverless. It has to run on some compute. It has to run on some VM or container or physical server. But the point is, actually, you can only see the usage, the function like we do algorithmic takeoff. That's why we call it serverless. मैं तो personally I don't like that terminologies जो confuse कर देती हैं लोगों को. That's why I call it stateless.
So the main reason is that you don't pay for the server. For the
Correct. Absolutely. You don't. Yeah, absolutely. We don't pay the server or the instance. We only pay for the consumption. We only pay for the consumption.
for the CPU cycle.
Exactly. Exactly. Number of transactions generally you service पे depend करता है. Number of transactions पे, number of calls पे.
सर
जी.
ये जो कंटेनर है इसमें हम किसी भी लैंग्वेज को मतलब कोई भी सर्वर डिप्लॉय
Yes. Yes. That is the beauty of container. Any language, because it only requires the container runtime. It is not even dependent on the operating system.
सर कौन से फ्रेमवर्क है जो कि ये कंटेनर के फंक्शनैलिटी प्रोवाइड कर रहे हैं
आप तो CNCF की वेबसाइट पे जाना ओपन सोर्स फैसिलिटी हवाले प्रोवाइड करता है तमाम कंपनी प्रोवाइड करते हैं.
सर अगर ये ओपन सोर्स है
Yes.
तो मैं तो कभी अपना मैं मेहनत करके मैंने एक सॉफ्टवेयर ओपन सोर्स नहीं करूँगा क्योंकि मेरा मेहनत भी उस पर लगे तो ये लोग क्यों लेना ओपन सोर्स प्रोवाइड कर रहे हैं
इस सवाल का जवाब थोड़ा डिफरेंट है. कुछ सभी अच्छे बात की बात कर रहे थे कि कुछ लोग इस इरादे से काम करते हैं हम इससे क्या गेन कर सकते हैं और कुछ इस इरादे से करते हैं कि हम क्या दे सकते हैं. तो ओपन सोर्स जो है वो देने वाले लोगों की कम्युनिटी है और आप कर सकते हैं तो देने वाले लोगों की कम्युनिटी है ओपन सोर्स. तो मेरे टीचर थे पास से पढ़ाऊंगा तो रात भर बोलना है वो कहते थे कि अगर ये पायरेसी ना होती तो हम थर्ड वर्ल्ड कंट्रीज के बच्चे पढ़ नहीं सकते.
शायद सर ये हमें
तो ओपन सोर्स पायरेसी को कवर करके
एक ये है कि सर हम उसके सॉफ्टवेयर यूज कर रहे हैं ओपन सोर्स जो कि हमें लग रहा है कि ये ओपन सोर्स है लेकिन वो बैकएंड पे हम सभी बेनिफिट्स जैसे कि हमारा रिप्लेसमेंट हो सकते हैं.
Here, it is cybersecurity and open source. To certain extent, you are right, because people know all those technologies are developed. Uski in-depth details are available publicly. But generally, it's not easy to break that. And दूसरी तरह ये कि vice versa is not true. ऐसा नहीं है कि open source नहीं है वो कभी भी hack नहीं होगा. सारा ही कमर्शियल सॉफ्टवेयर हैक होता है. सारे हर किस्म के सर्वर, हर किस्म के सॉफ्टवेयर, हर चीज हैक हो सकती है. हर एक पे साइबर अटैक होते हैं. तो मतलब आप ओपन सोर्स को दो एस्पेक्ट से यूज करते हैं. कमर्शियल एस्पेक्ट. फर्स्ट स्टेप इज लर्निंग एंड कैपेबिलिटी डेवलपमेंट. आप उसका जो अनपेड वर्जन है ना आप उसको यूज करें. जब आप उसको कमर्शियल स्केल पे लेके जाते हैं अब अपनी प्रोडक्ट को तो फिर आपको सपोर्ट भी चाहिए. फिर आप पेड सर्विस लें, ये पेड सपोर्ट लें. फॉर एग्जांपल लिनक्स है. लिनक्स इज ओपन सोर्स अवेलेबल बट कमर्शियली नो वन रन्स द अनपेड version of it. They pay